Hi, grade 9s. Today we're going to be learning about different types of chemical reactions. Just to summarize, those are a few of the ones that we mentioned last class. I'm going to quickly go over the first two because we have talked about already. Synthesis involves the combination of two substances to form a single product. So for example, last class we were talking about how we could take magnesium and oxygen to form magnesium oxide. So just having the two single elements combined to form a compound. And decomposition is just the opposite, separating or breaking down compounds into the individual parts. And so last class, we looked at a video where they took water and passed electricity through it to break it into the individual components, hydrogen gas and oxygen gas. Today, we're going to start by talking about single replacement. In single replacement, an element reacts with a compound. So here, this first one is our element. It's on its own. Reacts with a compound. A compound is two or more chemical elements that are bonded together. And so here, an element reacts with a compound to replace one of the elements in the compound. So here we have a swap. So these two, the purple and the dark green, are swapping. And so now we have a new compound that's formed. You can think about it with these pictures, or if it helps you, you can also use the general equation. A plus BC yields B plus AC. So here we've just had a swap. The A and the B just swap places. Okay. The example that we're going to look at is copper and silver nitrate. Copper and silver are both metals, and so what they can do is they can swap places. If you remember ionic constants, we have a metal and a non-metal. What we can do here is that we can go from one ionic compound to another ionic compound, just because metals both have the same kind of want to lose electrons, and non-metals want to gain electrons. So here, the copper and the silver will do a swap. We'll watch a video and then we'll get back to talking about this a little bit more. So in this example, this is a copper foil, kind of similar to aluminum foil, but just made out of copper. Put it in a beaker, and we're going to add a silver nitrate solution. It is an aqueous solution, which means that the silver nitrate is dissolved in water. And this video is sped up just so that you can see the reaction faster. But you'll start to notice that some silver crystals are forming on the copper. We did this with our grade 10s during Christmas, and they were really excited because they thought that we could transform copper into silver and then just like sell it and get really rich. But I think they kind of forgot that we had paid for the silver. It was just in solution in that liquid. So remember, the law of conservation of energy says we can't make something out of nothing. In this case, it's just a single replacement reaction where the two are swapping places. The copper and the silver are swapping places, but they were always there from the beginning. You might also notice that the water is turning bluish. You think of like the Statue of Liberty, that's kind of bluish. It's also because it's made of copper. Okay, let's talk about this for a bit. So observations, we noticed that the copper turned into silver because they swapped places. And so there was a color change to show that a new substance was produced. And we also noticed that the liquid turned blue. And our last step here would just be to balance the equation, and just remembering that we can't change any of the subscripts or these little numbers down here. But if we wanted more silvers, for example, so in this case, I needed to add a 2 here because there's 2 nitrates. And so we could add coefficients. But once I add this coefficient, this applies to everything. And that's why we added another coefficient there. Okay. We're going to talk about double replacement. It's similar, just that in this case, we're starting with 2 compounds, and now 2 compounds are reacting with each other, and 2 elements are replacing each other. So you can look at the visual here to see what's going on, or you can also take a look at the general equation. AB plus CD yields CB plus AD. So now we have 2 elements replacing each other. In the previous one, we had a single element with a compound. Now we have 2 compounds and 2 compounds, and there's been the swaps. An example of a double replacement reaction is copper 2 chloride and sodium phosphate. And we'll watch the video first, and then we'll talk about it.
Hello, at this station, we will be combining copper chloride and sodium phosphate, and we are going to form a precipitate. Remember, a precipitate or precipitate is a solid product. So I'm going to start out with copper chloride. This is copper 2 chloride, beautiful blue solution. And to this, we are going to add our sodium phosphate. Our two products are going to be sodium chloride, that will be in solution. And then our precipitate will be copper phosphate. So I'm going to do this up close. So we should see a solid form. See that chunky stuff on the top? That's our copper phosphate. So this is an example of a double replacement reaction. It's beautiful.
Okay, so what was happening here is that the copper and the sodium are swapping places. Okay, and so now we noticed that there was a change. It turned more opaque and gel-like. And so we know that there's been a chemical change that happened, and it went from two liquids into something more solid. And once again, we need to balance our chemical equations. We're going to move on and talk about acid-base neutralization. It's a special type of double replacement reaction that involves an acid and a base reacting to form salt and water. So acids and bases, all you need to know for now is that acids generally start with an H in front of them. So if you see H with another element and it's not water, it's probably an acid. And if you see an element that ends with an OH group, that's going to be called a base. And so if we have an acid or a base and we mix them together, something called an acid-base neutralization can happen, and they'll basically neutralize each other and become water that has a pH of 7 and is neutral, and then we'll also have a salt. In this case, the salt isn't necessarily table salt. It could be. The salt is just going to be whatever the first two elements were from our products, okay? And so if we look at our general equation, we have HA, which is the acid, because it starts with the H, and BOH, the another element with an OH group or a base. And then our results are going to be, or products are going to be water, and then salt, which is just composed of the elements from the products. Okay? So we'll take a look at the demo first, and then I'll talk about it a bit. So now we have equimolar solutions of HCl and NaOH. HCl is our acid and NaOH is our base. Universal indicator changes colors just to show us the pH level of something, just to prove to you that we actually have two different substances, because in this case we have two clear liquids. So just to prove to you that it's actually different substances. This one is an acid and this one is a base. And so we know that our acid is an acid because the pH is less than 7, and then the pH of this one is greater than 7. When we mix them together, you'll notice that there's a color change, and now it turns green, and this universal indicator will turn green in the presence of a pH of 7 that is neutral. So we know that's neutralized. So in this case, they use universal indicator. When I did this in class with my grade 10s, we use phenolphthalein, which is another indicator. But same idea. We just know that it gives us a color change to tell us if we have acids or bases. Phenolphthalein changes pink for bases. You guys might remember it from grade 8. I think with Miss Chow, you might have done an experiment where you're talking about the immune system, and she had you like with little containers of water or test tubes of water, and you had to go around pretending to shake hands with each other, and then at the end, she put phenolphthalein, and if you were infected, your test tube would turn bright pink. So you might remember it from then. In the video, they use universal indicator, but same idea. They prove that we started with an acid and a base and then ended up with something neutral and a salt. In this case, if we did combine HCl, hydrochloric acid, and sodium hydroxide, we would end up with sodium chloride, so just salt water. So I could, if we had the right proportions, so in the right concentrations of these things, we could take this acid and base, combine them, and hypothetically, like, be able just to drink it or pour it down the drain, no problem. But remember, you never want to eat or drink anything in the lab. So we didn't actually do that. Combustion is my favorite one, so I want to end with that one, and then I'll talk about your assignment. Combustion involves an organic substance reacting with oxygen to produce carbon dioxide and water, as well as heat and light energy. And when you think of combustion, you might think of like explosions as well. It doesn't always have to be an explosion. The general equation is going to be CXHY. That's just going to be an organic substance that contains carbon. And then we have oxygen, which is part of the Hofbrinkel's oxygen. And then our products are being carbon dioxide and water, both as gases. So it can be fast, like in fireworks, or it can be really slow, like in cellular respiration. We're going to look at an example of an explosion because I'm really excited about that. Please don't try this at home. When we're back in the building, I'm sure that Mr. Chung can try this with you guys when you're in Chem 11. First of all, just the warning, don't try this at home. So I like to call this gummy bear sacrifice, and you'll find out why in a bit. We'll just watch the video and then I'll talk about it. Oops. So now they're just pouring the first chemical in there in order to release a lot of oxygen gas. And so by heating it up, we're releasing a lot of oxygen gas. And then the oxygen gas reacts with the sugar, and we see this reaction. Okay, so let's talk about what happened. So here we had sugar and oxygen gas react to form carbon dioxide and water. So in order to get the oxygen, we don't have just pure oxygen in the air, we have a bunch of other gases. They take another compound and then heat it in the flame, and oxygen is released, and we have like a lot of oxygen. So that kind of speeds up the process. And then you notice that there's a lot of light and fused gases that are released, and that's the carbon dioxide and the water. Once again, don't try this at home. If we were to try this at school, a good place to try is in the fume hood because it's going to collect all those gases. Otherwise, it might set off the fire alarms or the smoke detector. Or outdoors is good as well. So I'll leave all of these on Google Classroom so you can see them again if you want to. I wanted to quickly talk about your assignment. So for today, we're done with all our chemistry work for the term. I would like you to, first of all, complete the worksheet on classifying and balancing reactions. It looks like this. Second thing is you can start your last video assignment, number 4. For your last video assignment, you need to choose 6 questions from the worksheet. The worksheet will have more than 6 questions. So if you want to, you could actually just complete 6 questions. However, you do need to make sure that you choose one of each type of reactions. So we talked about synthesis, decomposition, single replacement, double replacement, neutralization, and combustion. So you need to complete 1 question from each category at least, okay? And then your video assignment is going to be to take those 6 questions from one from each category and explain what type of reaction it is. So for example, like this is synthesis because 2 elements are being combined. And that would be enough. And then you also need to balance it and show all your work balancing it. There's 2 options for your last video assignment. You can either use Screencastify Submit, or you can record the video using any other method. It's up to you how you want to have your explanations. If you want to narrate as you go through the video, that's good. Or if you just want to add captions to your video and have like kind of closed captions on the bottom, that's okay too. This part is optional. I am attaching the notes, and I'll attach the filled out notes as well so you guys can fill them in. It's optional for you guys to fill in the notes. If it helps you learn it better, go for it. It's totally optional. I do want you guys, however, to fill out the worksheet. And once again, you don't actually have to fill out all of the questions. You do need to choose 6 reactions. So 1 from each type, and they're listed there. So 1, 2, 3, 4, 5. And the neutralization is not on here, but you do need to find neutralization as well. Okay. So make a video to explain the reactions and show all your work in balancing the equation. If you can't find a neutralization on this worksheet, you can just find another neutralization example. If you have any questions, please let me know. Send me an email. This assignment is due next Wednesday, June 10th. Okay. By grade 9s, it's been a pleasure teaching you this term. I hope you have a good summer, and I look forward to seeing your last videos. Take care. Bye.